Welcome to another episode of Art of Machine Design. This is the quick guide to Euler buckling. If you haven't subscribed, subscribe now and hit the like button. Let's get started. This is the what, where, when, and how to use Euler buckling. In summary, if trust, then God. If it's a truss, then do your Euler buckling analysis. So Euler buckling is applicable to trusses. What are trusses? Links in compression. When you have a member that exceeds a length to critical dimension width or thickness ratio more than 5 and it's in compression, you should consider Euler buckling. Where do we see this? We see this in an array of industrial applications, such as buildings, home roofs. However, more importantly, you see it in somewhere like a circus, like this in Cirque du Soleil. Those members are actually in compression. So if they want to stay on top, they have to make sure that those legs are passing our Euler critical criteria. What does the engineering model consist of? The engineering model looks as follows. It has to be linear elastic, as you can see here. The material is isotropic. For this model, we actually ignore the weight of the beam. And in this one particularly, we do not take into account eccentricities. And we also assume that the material has a uniform cross-section. Depending on the boundary conditions, we look it up, what the coefficient is of the geometry. It comes up to two equations. The critical stress, which is the force critical over area, and the critical force. Now let's get to do that analysis. You can follow the analysis in the direction in which you calculated, but in this case I want to show you starting from the critical stress and working our way back. So what's important is that the critical stress in Euler buckling is less than half the yield stress. So in order to do that, we need a critical stress. A is the area, so we get that via the geometry. Critical force, we have an equation. I, area moment of inertia, we get it via the geometry. The C, we get it by the configuration of the column, whether it's fixed, pin free, roller, you find that out. And that's where actually the critical part comes in. Where do you get that information to convert the real world problem into an engineering model? You can calculate the slender ratios, which give you some information about the type of column. Typically, you're looking at a slender ratio between 80 and 120. And that's it. So if trust, then God. If truss, then Euler buckling. Subscribe to the channel, give the like button. Until next time.